and then 4 times A, which is 8, times C, which is a -3. I'm going to close this, and this is all over 2 times A, so it's 2 times 8. Okay? So now what we're going to go through here, it's basically like the order of operations. I'm going to kind of look to see, do I have any signs that I can look at? Do I have anything that's being squared, which I do and I do. So let's go ahead and kind of further simplify that. We have x equals, if you do a negative times a negative, you get a positive. I kind of always looked at it like this little smiley face, and the smiley face is always happy because he's smiling. So negative, parenthesis, a negative, that's a positive. So we have a positive 5. Then we have plus or minus the square root of, okay, I'm going to kind of look at this right here. The reason why I wanted to put this in parentheses is because this is saying I have -5 squared, which is -5 times -5, which would be what? -5 times -5 is going to be 5 times 5 is 25. Signs are different, so it's positive, right? Well, if you don't use parentheses, you're actually going to end up squaring the 5 and then keeping the negative sign, which is not correct. So make sure you use your parentheses right there, okay? -5 squared is a positive 25. Then we have our -4 times 8, and we have all of that times our -3. So if you do -4 times 8, we get 32. 32 times 3 is 96. Then we have a negative and a negative, which would make that a positive, okay? So that's going to go right here. All over 2 times 8 is 16. Good? Okay, so still kind of following the order of operations, we need to simplify underneath the square root. So we have x equals 5 plus or minus the square root of 96 plus 25 is 121. Close that square root, put it over 16. 121 is a perfect square. If you take the square root of 121, we get 5 plus or minus. I know it's kind of redundant, but writing all the steps will really help you keep from making a simple mistake. The square root of 121 is 11 over 16. We've done problems before where we had an imaginary unit and like the answer could be left in those terms. If you notice here, I could actually evaluate this root and I could actually pull out an 11. There's no imaginary unit. I just have 3 different numbers. It is telling me that there's a plus or minus in between them, which basically just means that I have 2 answers right here. So we're going to actually write both of them and then solve it. So we have an x equals 5, and then just pick one. I'm going to pick the top one, which is a positive, over 16. And I have an x equals 5 minus 11 equals 16. Okay, so if you look at that top one, I have 5 plus 11, which is 16 over 16, and 16 over 16 is just 1. And then right here I have 5 minus 11. Signs are different, so you subtract, keep the sign of the larger. I get a -6. And then over 16, both of those are actually divisible by 2. So I would get 6 divided by 2 is 3. Signs are different, so it's negative. And then 18 divided by 2, which is 8. The signs are the same, so it's positive. Let me write that right here. I actually divided the top by 2, and I divided the bottom by 2. Okay, so I'm going to slide up just a little bit. So in your homework, I believe you should just have a text field that is kind of like this, and it wants the answers to this problem. I'm unsure if it would have the braces. I'm unsure if you even need it, but you could go ahead and write the answer It may just want 1 comma -3/8. It may already have braces, or you may need to add braces. Regardless, if you notice, we actually have two like numerical values. Because of our plus and minus, we will always have our two answers right there. Okay, so that's how you do the quadratic formula.